Lesson 2's homework on side angle side proofs. We're going to look at our second congruency statement. So in lesson 1, we went side, side, side. Today we're going side angle side. So for our first one, we're going to use side angle side to prove the following triangles are congruent, and we want to draw in the missing labels. So if you look at picture A, they give you two sides, which means in order to get side angle side, and remember order is important, since our angle must be between our two sides, we're going to be looking at angle A being congruent to angle D. It would help if I put the A in there. Angle A is congruent to angle D. For part B, they've given us a side and an angle, and now we need to make sure that we pick our side or additional side that's going to sandwich our our angle in between our two sides. And that would be that AB is congruent to ED. So those are going to be our two side angle side patterns based on what they gave us. And now let's look at a couple proofs. Number 2, angle 1 is congruent to angle 2, and BC is congruent to DC. They want us to prove that triangle ABC is congruent to triangle ADC. So I'll start by making my chart. So we have our statements and our reasons. So the first thing that it tells us is that angle 1 is congruent to angle 2, and that BC is congruent to DC. So this is a nice friendly one because they've given us two things that are congruent in our givens. So we don't really have to work that hard to complete this proof, and a reason for that is given. The next thing is, well, since we're out of givens, the only options we have are either reflexive sides or vertical angles. And I see a reflexive side here at AC. So AC is congruent to AC. That would be our reflexive property of congruence. And now let's look at our triangle. In the triangle left, we have side, angle, side. And in the right triangle, we have side, angle, side. So step 3, triangle ABC is congruent to triangle ADC. And our reason is going to be side, angle, side. Now for this one, they ask a follow-up question of describe the rigid motion or motions that would map ADC onto ABC. And this one to me looks like a very simple explanation, and I see it as a reflection over side AC. So if you reflect over that reflexive side, you will get your two triangles on top of each other. In the third one, they give you a lot less information here, and we're going to have to do a little bit more work for this piece. It tells you that KM and JN bisect each other, and that's the only thing that they tell us. So as we start here, we make our table, and we start to fill things out, we should notice that very little was given to us here compared to some of the other problems. So it's likely that this is going to take a couple more steps and a little bit more work. So for the first one, we'll write down our givens. KM and JN bisect each other. And the nice part about this is this each other part. All right. So when they tell you like KM bisects JN, only one of them's being cut in half. When they use the words each other, that means both are going to be cut in half. So if we cut KM in half, we get KL congruent to JL. And if we cut JN in half, we get JL congruent to NL. So the nice part is about that, and I forgot my reason for the first one, given. The nice part about that is since they both are based off the same reason about bisects, we can put them in the same step. So KL is congruent to LM. And then in the same step, I'm going to put JL is congruent to LN. And the reason for that is a bisector divides a segment into two congruent segments. And that's one of our lengthier definitions. So the nice part about putting both of those together is that we don't have to worry about writing it twice. But now we're out of givens, and all we have is two sides. So our goal is we have to look for either a reflexive side or vertical angles. And I don't see any reflexive sides here, but I do see my vertical angles. And to make my life easier, I'm going to call them angles 1 and 2. So that this way I don't have to worry about screwing up the order of the letters as I write them out. So step 3, angle 1 is congruent to angle 2. Our reason for that is that vertical angles are congruent. And we want to write more than just vertical angles there. We want to make sure that we write that they are congruent so that we know we're establishing something to be true. Well, now as I look at our triangles, I have side, angle, side, and side, angle, side. Notice I started counting from the 1 hash mark in the left triangle, so I start from the 1 hash mark in the right. So this is enough information now. Triangle JKL is congruent to triangle NML, and our pattern is going to be side, angle, side. Now this one also asks to describe a rigid motion or motions that would map NML onto JKL. And the one thing I want you to notice is I want you to notice the order of the letters. So the N and the J match up, your K and your M match up, and then obviously your L's are going to be the same in the middle. So it's going to be a rotation of 180 degrees, and we're going to center it at point L, that meeting point between the two triangles. So that would get our J on top of, or N on top of J, and M on top of K, and obviously the L would just stay the same.